Hello and welcome to this tutorial of the TCGA.ql query language DSL for the TCGA roadmap. To begin, within your Chrome browser, open the TCGA Toolbox app, which is available in the Chrome Web Store. After opening the TCGA Toolbox app, click on the Modules tab, load module by author, select author David Robbins, select the module TCGA query language, and load the module. This will immediately take you to the TCGA.ql documentation page. Now, TCGA.ql is a JavaScript-based domain-specific language that is used to generate Sparkle queries run against the TCGA roadmap. So to begin using it, let's open the JavaScript console by the menu, going to Tools, and then JavaScript console. Now we can begin to follow along with the documentation. The first thing the documentation points out that we should do is create a query object. Let's do that now. Now we have a query object. In order to see what types of filters are available on the query object, we can use the query.filternames accessor. I did not use Q as my variable name, I used query, so I needed to type the full word query. As we can see here, there are 6 different filters available corresponding to the 6 data types that are used to annotate data in the TCGA roadmap. Let's see what diseases are available in the TCGA roadmap. This immediately returns an object, and if we open that object, we can see that there are 27 different data types or disease studies available. Let's pick the GBM data study, or disease study, excuse me, as the disease study that we will learn more about. Let's see what data types are available for GBM. Now, in order to constrain by the GBM disease study, all we do is provide that as an argument to this diseases function. Let's type GBM here. And now we will get a list of the disease studies that are available for the GBM. These disease studies are only the ones that are available in the GBM. So let's pick the one that we're interested in here. Perhaps protein expression would be something that we're interested in. And let's take a look at the Sparkle query that is being generated behind the scenes. So if we type in our full DSL string here, we can now we've constrained the query object according to those two things. Now, in order to take a look at the Sparkle query, as I mentioned before, this is a Sparkle-based domain-specific language. We have 2 options. One of them is to say query string, which provides us with a string that could be used in other programmatically, perhaps. Or we can also say print query, which simply prints the current query string to the console. And here we have that query string, but also returns the query object as well for use in chaining. Now that we've done that, let's go ahead and explore the Sparkle query a little more in depth. We see that what we're extracting from the TCGA roadmap is the file name and the URL, and that the list of file names and URLs is being constrained by the GBM disease study here and the protein expression data type here. All right, well, in addition to building queries, sometimes we perhaps would like to run a query, so let's do that now. Notice that I did not have to type in all of the constraints again each time that I access the query object. Those constraints are saved on the query object. Now the results that we get are in the form of a Sparkle results JSON structure, a head and results. Within the results, we have a list of bindings, and each of these bindings corresponds to the file and URL that we see here. So in each one case, we have a file and a URL. Here we see that the file name is description.txt, And this is the URL in the TCGA's open access repository that contains that file. Let's try a different query to demonstrate that we can chain all of these things together. Let's select a different disease study, perhaps let's select multiple disease studies in this case. Let's say in addition to GBM, we are also interested in BRCA, the breast cancer disease study. And instead of the protein expression data, we are interested in the clinical data. Now, when we run this query, it's going to take a moment for the results to come back. Now, although the results object is immediately returned, it is empty currently. And you're probably wondering how this can be interacted with programmatically if you wanted to use this in another program, as you should be able to do with a DSL. The answer is that the result object that's returned is a jQuery promise. So we can say results2.done, and using the done function, we can assign a function that will be run as soon as our data comes back. So now we see that as soon as the data came back, it was logged to the console right here. And this done function also returns that same object again. Now if we take a look at the results object, now that we know the data is back, we can see that within this object, the head and results have already been populated. Again, this is the Sparkle results JSON data type. All right, well that's all well and good for direct interaction through the command line using the DSL. But another thing that a DSL like this enables you to do is to build novel user interfaces. So let's take a look at one of those user interfaces. Let's refresh the TCGA Toolbox just so that we're starting with a clean slate. Go into modules, and in this time, instead of loading the query language, we're going to load the query language UI, which depends on the query language. So let's load that. We see that the query language was again loaded. Here's our TCGA.ql docs again, but now we also have this second tab, the TCGA query language. Now this provides us with a column browser type interface. Below we see listed the file names and the URLs. Here we have a query listing that can be toggled, hidden, or shown. And above we have a list of 3 filter types. So let's select a filter. Let's select again the GBM filter type here at the bottom. And now when we select this second column, whatever is populated here in the second column will be constrained by the values of the first column. So let's see what centers have data for the GBM. We see now that it's immediately querying the Sparkle endpoint to load the types of centers that are available for the GBM. Okay, now we see the many center types, the many centers that have provided data for the GBM data study. Let's say that we only want the data that comes from mdanderson.org, or we'd like to see what data types mdanderson.org has provided. So let's select data types as the final value here and see what we have from them. As we can see, MD Anderson provides the protein expression data that we looked at earlier. Now if we take a look at the query listing here, we can see the query being changed as we select different values up here. So if I was to select this other cancer type, we immediately see that reflected down here. And if I was to select 2 cancer types, I can immediately see how that type of query is structured. And this just illustrates the ability of Sparkle to serve as the foundation for a variety of domain-specific languages. Now let's go ahead and run this query and see what results we get. Okay, our results have come back now, and we can see that we have a list of files with the file name and the URL to that file in the open access TCGA repository. If we select one of these files and click on the link, we will immediately be taken to that file. Hopefully I did not pick one that is too large. And here we have that data file. This concludes this tutorial of the TCGA.ql query language DSL for the TCGA roadmap. TCGA.ql is a JavaScript-based domain-specific language that is built on top of Sparkle in order to browse the data files available in the TCGA open access repository. Thanks for watching.